So we're going to look at how to solve the second order differential equations and the I'll do, there's three different sorts really. Okay, so we'll do one of each. So we're looking at how to solve second order differential equations, and the general form of the questions you're going to get are when we've got a d2y dx squared plus b dy dx plus c y, and that's why it's second order, because we've got this d2y dx squared there, equal to something over here, something in terms of x over here. Okay, you happy with that? Okay, and what I'll probably do while we're going through this is might use this other notation, which is a y double dash for the second order, y dash plus c. What's that? Okay, so that's the sort of questions we're going to get of that form, and they're just different ways of writing it. Okay, so can you remember the method? If I yeah, so what I think I'll do is we'll do it by doing an example. Well, actually, what was the method? What do you do first?
You make the left side 0.
The left side?
Right side.
Yeah, so first of all, the first thing we do, and this is the same when we're doing those first order equations as well. So first step is solve the reduced equation. Do you know what I mean by the reduced equation? Yeah. So the first thing we're going to do is solve the reduced equation, and it's a y double dash plus b y dash plus c. I've missed a y off there. Why didn't anyone tell me that? Plus cy equals 0. We're going to try and solve that. Okay? And we'll get a solution to that. We'll get a y equals, that's when we've got a solution. And what do we call that when we've got that y? That's going to be the complementary function. And then we're going to try and find a solution for the whole thing. And the y there is going to be the particular integral. And then the general solution is those things added together. Are you happy with that? Okay. So how do I solve this reduced equation? Well, what we do is, you're talking about the auxiliary equation, yeah? So if I have this thing, a y double dash plus b y dash plus cy equals 0, then what's the idea? Can someone tell me? Yeah, we're going to let y equal, what did he say, Vlad? E to the mx, yeah? Or a e to the mx, or something like that. Okay? You got that? Let's put we can put a constant in front of there, but it doesn't matter. It's not going to make any difference for this thing here. Okay. In fact, let's do it. We're going to let y equal a e to the mx. Okay. So the reason for this is when I then put this y in here, I'm going to get a times the second differentiation of that y. What's the second differentiation of that y? Am squared, yeah, because the m is going to come down on the first differentiation on the second one. So it's going to be am squared e to the mx, yeah? Okay. And then what's the y dash going to turn into? And then the c is just, the y is just what we've got here. Do you get that? And you put it equal to 0, and then we factorise it. So you should be able to see that I can take a e to the mx out, right? So I factorise the whole thing, and I get a e to the mx outside, and inside what do I get? I get a m squared plus b times m plus c, and that all equals to 0. Okay? So I'm trying to find the values that are going to make this thing equal to 0. But you should see over here, if a is a positive, if a is just a constant, not 0, as long as a is not 0, then this thing here can never be 0. Okay? So I only have to make this thing equal to 0. So that thing there is called the auxiliary equation. And that's the way we're going to solve these things. So I only have to worry about this quadratic here. Now, this quadratic here, depending on what a, b and c are, is either going to have 2 roots, 2 equal roots, or complex roots. Is that right? Okay. So we've got 3 situations. So we'll do a question on each. We got the first the first one I'm going to give you. We're going to try and solve the first one now. Is going to have 2 real roots, 2 different real roots. Okay. So we'll call this situation 1, or yeah, we'll call it just question 1. And this is going to have 2 real roots of the auxiliary equation. Okay, and then we're going to see if we can solve it. So let's do, yeah, this one here. Okay, so the question we're going to do is 2y double dash minus y dash minus 3y is equal to, what should we say? What do you reckon? Doesn't matter, does it? Sin x? You want with an exponential? E to the x? Okay, just e to the x then. Okay, so what's the first thing we do then? The first thing we're going to do is we're going to solve that reduced equation. Okay, so we're just going to solve, or try to solve the reduced equation 2y double dash minus y dash minus 3y equals 0. And then we do exactly what we did before, but I don't really have to put that step in now because I know I just make the y's as something e to the mx, okay, and then solve the auxiliary equation. So I'm just going to skip that bit and I'm just going to write down the auxiliary equation for this, okay. So what's the auxiliary equation? Uh, 2m squared minus m minus 3 equals 0. And I'm going to try and find the value of m, and then I can just put it back in for my y value. So can someone factorise this? 2m take 3 and m plus 1. You happy with that? Yeah, that's fine. So therefore, m equals and therefore, what's my complementary function then? I'm going to write it as y with a little c on it, I think. What's my complementary function? I've got my m values. What did I say y was? When I did it with the a, b and c up here. Yeah, I should have 2. I should have a, e to the minus x. 3 over 2x. And that's the complementary function. Everyone happy with that? And now we're going to try and solve the whole thing. Get a particular integral and then add the 2 things together. Like that. Okay, so let's go back and now try and find a solution for the whole thing. The whole thing was, what was it again? Yeah, I can't use two different notations, can I? That's just minus dy dx, yeah? So, who can tell me what am I going to make e to the x? Oh, sorry, what I'm going to make y for my what do you think? A e to the x. I don't think I'm going to use a again though. Is everyone happy with that? Yeah. So we're going to try y. I'm going to put yp here for my particular integral equals c e to the x. Is that okay? Is everyone happy with that? So what we're going to do is we're going to write this thing out again, but where we've got a d2y dx squared, I'm going to write d2yp dx squared. So the second differentiation of this. So what's it going to be? Yeah, just turns out to be the same. And this one here, just the same. And this one here, just the same. Equals e to the x. Drop my c's, okay. There's a c there, isn't there? Okay. So this means when I put all this together, I've got 2c minus 1 minus 3. Is that negative 2? Negative 2c e to the x equals e to the x. So what's c? Can e to the x ever be 0? So can I just say that negative 2c equals 1? Yeah. And so c is minus a half? Okay. And so I get my particular integral then. Is IP equals, what was it? Minus a half e x. Now we know what c is. Yeah? And then the general solution is going to be the complementary function plus the particular integral, and I think that was a e to the minus x plus b e to the 3 over 2x minus a half e to the x. That's it, isn't it? Yeah? Okay, so that's it there. Now if you want to find out what the a and the b are, what else would I need in the question? Some just boundary conditions. How many boundary conditions would I need for a second order one? Yeah, because of those two constants. Okay, any questions on that? Let's summarise this, yeah? I think this is the way I did it before, so I'll just summarise this. When the auxiliary equation has two distinct real roots, then the complementary function has what form? It's a. Let's just move this down a bit. Yeah. Say again. Sorry, Gareth. Yeah. Yeah, the first mx.
Yeah, and then plus b.
And 2x. Okay, good. So let's see if they're distinct, right? Now the actual method is exactly the same if they're the same roots, equal roots, or if they're complex roots. The method is exactly the same, except you can do something using de Moivre's to put those things together. Okay, so shall I do one now with equal roots, or do you want me to give? Say again.
AX.
Yeah. Yeah. So should we do an example like that?
Do the complex ones.
Do the complex ones now?
Yeah.
Okay. So, see, I can never remember what the outcomes are, but let me just write this down as well then. So, I'll put this thing here. You'll get the same thing. So when the auxiliary equation has equal roots, well, when the auxiliary equation has equal roots, you do exactly the same thing, except these m's are going to be the same. Yeah? So if they've got equal roots, these m's are going to be the same. They'll have an a and b, but I can just add them together and turn them into one thing. So that's no good. So we have a slightly different... and what is it then, Charlie? What's the slightly different form? So when it has equal roots, what form is it then?
AE to the mx.
Oh, sorry, hold on. Yeah, y, c.
Which is AE to the mx.
Yeah,
Plus bx e to the mx.
yeah, we stick that x in. It's like those other ones we do, where if you've already had the e, you want to chuck an x in there. And if you've already had an xe, chuck an x squared in there. Okay? Mx. Everyone happy with that? Okay, so we'll go straight to the third example where we've got complex roots. And then I think that's pretty much everything. You've obviously got to add the particular integral on as well. That's just the auxiliary equation bit. So there'll be another bit tacked onto that. So what should we do this time? Should we do when the auxiliary equation has complex roots? And should we put some boundary conditions in this one? Has complex roots. Okay. So let me find a question for us to do on that. Nice. Well, I'll tell you what we'll do. We'll do this one. I'll put boundary conditions in, but I'll make it easier in another way so we can see the thing. So I've got y double dash minus 2y plus 3y, and what I'm going to do is I'm just going to put it equal to 0. Okay. So I don't need to find this the particular integral for this one. Okay, because this would just be that. Okay. So I'll put it equal to. I tell you what, let's not make it equal 0. Should I just put it equal to a number? So it makes it a little bit harder, but not too much. What number should we have? 2? Just a number, yeah. 2's a nice number, isn't it? What's your favourite number? 74. Oh, 74 over 3 we're down to.
74 over 3.
Say again? Okay, 77. Okay. So the first thing we do is we solve the reduced equation, right? Solve the reduced equation. The reduced equation being y double dash minus 2y plus 3y is equal to 0. 2y dash, thanks, John. Oh yeah, and there as well. Okay. That's a 1 dash there, right? Okay, so we get the auxiliary equation. We'll go straight to the auxiliary equation, and we get m squared minus 2m plus 3 equals 0. Now, you already know the answer. Is this going to factorise? No. So I've got to do a bit of quadratic formula, right? So let's do the quadratic formula. What is the quadratic formula? What?
Yeah.
Have I copied down the question wrong?
Yes. Plus 1 plus 3.
Yeah. No, it's just me. It's my fault. That should be a plus, shouldn't it? Yeah?
Yeah.
That's better. Okay. So I thought I had to go all the way back then. Does that one factorise? No. Okay. So m is going to be equal to 2 plus or minus the square root of b squared. Well, b squared is going to be 4 minus 4ac. Is that minus 12? Do you agree with that? All over 2. Okay, so I've got m is equal to, well, what's I'm going to get here? 4 take away 12, is that minus 8?
Yep.
Yeah. So this is 1 plus or minus root minus 8 over 2. And what does that go to? What? I root. I thought you said pi. Root 2i, yeah? Okay. So I've got two roots. 1 plus root 2i, 1 minus root 2i. So what I'm going to do is, this is, you won't normally have to do this, okay? But this, I mean, it's the way I have to do it, 'cause I'm a bit thick. But I would now write down that my complementary function is a e to the 1 plus root 2i x, yeah, very good, plus b e to the 1 minus root 2i x. Okay, now that doesn't look very nice, but can we do anything with that?
You change it into a to the x multiplied by a to the 2ix.
I can change. I can. What do you want me to change it to? A e to the x. Yeah.
Multiplied by a.
I don't need the a again because I will get a squared. So I don't need the a again, but yes, I can multiply that by e to the root 2 x, and I'm going to put the I there. Okay? And shall we do a similar thing with this one?
Yeah.
And this is going to be e to the minus root 2 xi. Okay. Everyone happy with that? Okay. Right, Ryan, what are we going to do next with that? No? Take out e to the x. Thanks. So e to the x is coming out the front. And then inside I'm going to get a e to the root 2 xi plus b e to the negative root 2 xi. Okay. Next step. Anybody? Oh, right. Get your formula books if you haven't got them. Okay.
E to the I theta equals cos theta plus I sin.
Right. So can you tell me how I can rewrite this then? If I've got e to the power of something with an I in it, it's a complex number, right?
Yeah.
Okay. So I'll keep the e to the x there. What does this thing turn into?
A times cos.
This is all in brackets, isn't it? Yeah.
Cos root 2x
Very good.
plus I sine root 2x.
Is that b times I sin?
No, that's that. All of that is into that. Yeah.
Plus
I'm going to have to move this over a bit, else I don't think it's going to fit on. Okay. Okay. I think you're right because I want the e to the x times and everything, don't I? So shall we? I'll tell you what. Just for you, Joe.
that should be curly brackets. You've got a curly bracket at the start of cos x. So you missed the bracket out.
Am I missing? I'm missing two brackets out, aren't
Yeah.
Oh no, okay, no, put an extra bracket in, that's what I'm thinking. Okay, I just need a bracket there, yeah. Okay, go on then, Charlie, what were you saying? So that's that bit, isn't it?
Yeah.
Plus,
B,
yeah,
brackets,
yeah,
times, cos minus root 2
yeah,
x,
yeah,
plus I sine minus root 2x.
minus root 2, oh, board's going a bit weird here. Minus root 2 x, and that's it, isn't it?
Yeah. But isn't like cos minus root 2x the same as just cos root 2x? It's like cos.
Yeah, let's have a look at that then. All right, is everyone happy with that? So I've got some cosines there. Now, so what Charlie's saying is, these negatives on the right-hand side, cos the minus root 2x. I'm going to leave this left-hand side bit. I'm just going to write it out again. This is still the complementary function. It's still e to the x there. This is still a cos root 2x plus I sine root 2x there. But now let's see what we can do with this thing. Cos the minus root 2x.
That's just cos root 2x.
Yeah, that's just cos root 2x.
And sine minus 2 root x became minus I sine.
Real. So I can get rid of that minus in front of there. And because it's minus inside, I can bring it out the front. Very good, Charlie. So it's minus I sine root 2x. Brill. Okay, Joel, you watching? On and off. What do I do next, Joel? So keep the e to the x out the front. Yeah. Right, how many cos root 2x's have I got? I've got a plus b of them, right? I've got a of them there, and I've got b of them there. So we've got a plus b times cos root 2x. Right, how many... I've got a minus b I sines root 2x's. Do you agree with that? Now, a plus b is a constant, so should we just call it something else? C. Or should we call it new a or something like that? What do you want to call it?
Yeah,
K.
K.
Yes.
Okay, so a plus b is a constant, so I'll just call it a new constant. And what about a minus b? What about a minus b I? That's still just a constant, right? So what should we call it? Q?
Sine.
Now, obviously, K and Q, you don't need, you just call K and Q A and B or whatever you want them to do. But that's what we get. We get e to the x, K cos. So that there is the complementary function. Just like we did earlier in the questions, we wrote down a general statement. So if the auxiliary equation has complex roots, then what do we get here? What form does it have in general? This was particularly for this question. We've got this root 2x. E to the alpha x. What's alpha? Okay. E. Well, first of all, let's do it like this. E to the alpha x. Yeah. Times.
Constant, so A.
Yeah.
Cos beta x.
Yeah.
With beta being the imaginary.
Yeah. I'll put that in, and then we've got b.
B sine.
B to x. Yeah. Is everyone happy with that? And I'll just put on the bottom here where alpha is the real component of the root and beta the imaginary component. Now we didn't actually finish the question off, did we? Because we put it all equal to 5. No, we put it all equal to 77. Okay, so we should just finish this question off and then we're done, really, aren't we? Yeah. And I'll give you some to do. Okay, so we've got the complementary function. Now we've got to have a go at solving finding the integrating factor, right? So the question was y double dash minus 2y plus 3y equals, it was 77 we changed it to, wasn't it?
Yeah.
What we're going to what sort of form is y going to have?
A.
Just A? Everyone happy with that?
Double dash.
So what's y double dash? I forgot the dash again. Nothing.
Dash first.
Okay. What's y dash going to be? So I've got 3a equals 77.
Yeah.
Why did you pick 77?
So somebody said 75 and somebody said 74.
So a equals
77 divided by 3.
77 divided by 3. So that's a bit weird, wasn't it? And then, so the general solution? The general solution is y, it's the addition of the particular integral and the complementary function. So what was it? It was e to the x. Let's write it like this, shall we? It was a e to the x sine x root 2 x plus b e to the x cos x cos root 2 x plus 77 over 3. Okay, got it? And then I didn't give you, I said I was going to give you some boundary conditions, didn't I? Did I ever do that? No, so that's it. So, just to finish off, we write it down one more time. If the auxiliary equation has real roots and they're distinct, then what form does the complementary function have? Remember? That one, where M1 and M2 are the roots, yeah? Okay. If the auxiliary equation has equal roots, then what form do we have? Yeah, a e to the m x. The m's are the same, aren't they? Plus b x e to the m x. And then finally, if the auxiliary equation has complex roots, and the complex roots are alpha plus or minus beta I, then what does the form of the solution have? E to the alpha x yeah, it doesn't matter which way around it is, does it? Beta x. Excellent. Okay, and that's it really. Other than we didn't do any examples where we had boundary conditions, but that's the same as all the other questions, isn't it? Where you sub in and you try and find out what the content is.